Well, anyways, it's my pleasure to be here to speak to everyone. And I think in this series of talks, most people have been discussing recent missions to the moon, future missions, and some of the most recent scientific discoveries. And what I'd like to do today is try to tell you how we got to this point in time. So I'm going to start as far back as we can go in time and then bring us up to the present day. And in order to start, we'll start at the very beginning. This is 300,000 years ago when the species of a Homo sapiens first appeared in Africa. And at this point in time, the people who lived on the earth were not too different from us. They certainly would have looked up at the sky and seen the moon. They would have recognized that the moon traces a pattern of phases that lasts about 30 days in 1 month. And also, if they had good eyesight, not like myself, they would probably see that there were black and white spots on the moon, as you can see in this image here. So one of the first ideas that people had concerning the nature of the moon came from the early Greeks, namely Pythagoras, about 500 BC. And the Pythagoreans, they had a very theoretical way of looking at the universe, and they thought that the moon and the other bodies in our solar system were perfectly smooth spherical bodies. And because of this, the moon reflected all the light that came off of it. And the moon was, in essence, a giant mirror in the sky. And the way he explained the black and white regions on the moon is that these were just actually reflections of the Mediterranean Sea on the surface of the moon. Now, this idea might seem kind of odd by today's standards, but it's an idea that repeated over and over again throughout history. And one of the more recent accounts that I could find was in the 1600s, where the patron of Kepler believed that he could actually see Italy and some of the largest islands in the reflection of the moon. So I think it was Leonardo da Vinci who probably finally put this idea to rest. Now, Leonardo da Vinci, he was a genius from the Renaissance era. He had a good understanding of perspective. He understood optics. He was an inventor. And also, as you can see in this image here, he actually made an early globe of the Earth based on the current maps. Now, what da Vinci realized is that since the moon goes from this region over here on the Earth during the early portion, during the beginning of this, and then crosses the sky, as the moon moved across the sky, it would reflect different regions of the Earth. But what Da Vinci realized is that the spots on the moon do not change. They are fixed to the moon itself. And therefore, these black and white spots that we see on the moon are actually part of the moon itself. It's not a reflection of the Earth. So the next event that happened was in November of 1609, when Galileo Galilei took this telescope, which magnified objects by 20 times, and pointed it towards the moon and drew what he saw. Now, not only did Galileo draw the moon, but he also did a lot of other things. He was actually he's the father of astronomy in essence. He discovered the 4 primary moons of Jupiter, which bear his name. He saw the phases of Venus, confirming that Venus goes around the sun and not the other way around. He observed sunspots, and he actually also saw the rings of Saturn. So what did Galileo actually see? Well, this is one of his drawings, and Galileo drew things in a way where he actually was able to interpret what he was seeing. And what he interpreted is that the moon is not a smooth sphere, because he saw shadows on the surface of the moon, and these shadows changed in position and location and orientation over a lunation. And also, he paid particular attention to what's called the terminator. This is the line between the sunlit hemisphere of the moon on the left and the dark hemisphere on the right. And as you can see in this drawing, the terminator line is very uneven. And this is because the moon has mountains and valleys. Also, as you can see in this image here, he paid particular attention to these circular craters. And based on the way he drew the shadows of this crater, you can infer that this crater is actually a depression in the surface of the moon. Okay, so our next map came from a Polish astronomer, Johannes Hevelius, about 40 years later. And he used a telescope that was about 50 times in magnification. And what he realized is that he could actually see more than half of the moon's surface. What he realized is that by looking at the moon over and over again, he saw that the moon kind of wobbled back and forth in latitude, and then also wobbled left to right in longitude. And because of this, he was actually to map 59% of the moon's surface. He could actually see portions of the far side hemisphere. Now, based on this map here, you can see actually the regions of the far side, which are shown in this kind of extension of the map in the upper portion and this extension of the map in the lower portion of this map. Now, Hevelius, he also was very keen on paying attention to these circular craters, and he was one of the first people to suggest that these circular craters were actually giant volcanoes. And also something that would happen more frequently, he named the black regions of the moon after the oceans of the Earth. And this is just to show what Hevelius's astronomical observatory looked like. It's quite different from what we expect from an observatory today. It's actually just an extension of his house, which goes onto the other two houses surrounding him. So this would be a very heroic effort to get any observations made in these kind of situations. Okay, so what I'd like to do next is kind of give you some ideas of what people were thinking about in the 1700s and 1800s. And one of the common ideas, which I just mentioned, is that the craters on the moon are actually large volcanoes. And this was kind of inspired by the aristocratic way of education at the time, where they would send their kids on a grand tour of Europe. And eventually they would end up in something like at Mount Etna or in Naples at Vesuvius. And they would sometimes see these volcanic eruptions. And these volcanic eruptions, they were written down and they were illustrated, and they were very popular in the popular and scientific press at the time. And as you can see from this image on the right, this circular crater with these very aristocratic noblemen, it bears some resemblance to the circular craters that we see on the moon. Another thing that people talked a lot about at this time is that the moon's surface appeared to change over time. And some of the earliest accounts of changes came from some monks in the 1100s, where they saw some kind of eruption or explosion on the moon's surface. Now, people perhaps thought that these monks were a little drunk, perhaps, and they didn't actually see what they saw. But later in time, there were other scientists that were very well known who proposed that the surface of the moon changed with time. So as I mentioned, Leonardo da Vinci, he thought that he saw clouds on the surface of the moon. William Herschel, he's a very famous astronomer who actually discovered Uranus. He thought he saw 3 actively erupting volcanoes. And then there's other people who saw things appear and disappear. And even into the 1960s, there were 2 geologists at the USGS in the United States who thought they witnessed a volcanic eruption on the surface of the moon. And the third idea is that during this time, a lot of people entertained the possibility that there was actually life on the moon. And of course, from today's perspective, this seems kind of crazy, but I just like to say again is that prominent astronomers and scientists seriously entertained these ideas. So the first one is Johannes Kepler. He's the person who discovered the laws of motion of the planets in our solar system. He speculated on what the inhabitants of the moon would look like. He thought that it would be very hot during the day and they would have to hide in the shadows of these circular mounds that they built. Johannes Hevelius, he gave them the name selenites. William Herschel, again, as an astronomer, he thought the moon was very boring. But at the same time, he recognized that since there is life there, that therefore it's worthy to study the moon. And other people were a bit more imaginative. Some people saw the construction of roads and even a walled city and lakes and rivers and things like that. Of course, all of this turned out to be false. Okay, so things started to change, I would say, in roughly the early 1900s. And this is roughly around the time of the First and Second World War. And the idea is that people originally thought that these circular craters on the moon were actually volcanoes, but people started to think that maybe they were instead the explosion remnants of asteroids that smash into the surface of the moon at very high velocity, creating an explosion and creating these circular craters. And this is just an example on the right-hand side of a 100-meter diameter explosion crater that was formed in 1916 during World War I, and is still, you can still see this today in northern France. And if you look at this explosion crater, it looks almost identical to this picture of this crater on the other side of the screen for the moon. So this kind of gave credence to the idea that the craters on the moon are not volcanoes, but they're actually scars of asteroid impacts. And I think this idea was finally proven in 1960 when on Earth in Arizona, there's a crater that's about 1 kilometer across. Some scientists discovered a mineral called coesite. And this mineral can only form at extremely high pressures that occur when you have something like an asteroid hitting the surface of a planet at very high velocity. You cannot form coesite during a volcanic eruption. And also, if you didn't believe the coesite, you just have to go to Meteor Crater, because if you walk around the rim, you can actually find pieces of metallic iron. And this metallic iron, these are just iron meteorites. They're in essence the remnants of the projectile that formed this crater. Okay, so things changed dramatically in October 4th, 1957 with the launch of Sputnik, which was the first artificial satellite to be put in orbit around the Earth. Now, this, of course, was launched by the Soviet Union. And the unintended consequences of this is that the Americans were very intimidated by this. They felt that the Soviet Union was becoming more technologically advanced. And this led to the so-called space race, where each country, the United States and the Soviet Union, tried to outdo themselves by doing more and more preposterous things in space. Now, at this time, it's important to point out that whenever humans looked up at the moon up until this point, we only saw one hemisphere of the moon, roughly one hemisphere. And we noticed that there were black regions called the seas, the Maria, and also the bright regions, which are kind of the continents of the moon. But until this point, we had no idea what was on the other hemisphere of the moon. And this changed 2 years exactly to the date after the launch of Sputnik, when the Soviet Union launched Luna 3 in 1959. And they took the first photographs of the far side of the moon. And on the left, I show the original photographs from Luna 3, and on the right, I show a modern reconstruction of what this spacecraft would have actually seen using modern images from Lunar Reconnaissance Orbiter. Now, as you can see, on the near side of the moon, I mentioned there are lots of black regions, the so-called Maria or the seas, but on the far side of the moon, as you can see in this image, there are very few of these black splotches. And already in 1959, this tells us that the far side of the moon is different from the near side of the moon. And this is something that scientists like myself are still trying to explain today. And there's lots of theories, and we still don't know what the origin of this near side, far side dichotomy is. Okay, so after this, the Russians put a man in space, Yuri Gagarin, and then following this, the president, John F. Kennedy, in 1961, he decided that the only way that the Americans could win the space race was by doing something really preposterous, and this was to put a man on the moon in roughly a 10-year time period. But before we did this, we had to make sure that that the moon was actually safe to land on, that you could actually put a spacecraft on the surface, get out, and walk around. At this point in time, we had no idea what the surface of the moon was like. Some people proposed that there were thick layers of dust, and that if you stepped on the moon, you would just sink through this dust layer and die. So there was lots of ideas. And the first thing we had to do was to take images close up at the moon. And this was the NASA Ranger program, where they sent a rocket straight towards the moon and then took images until the rocket smashed into the surface. So here I'm just showing a sequence of events. The rocket's getting closer and closer to the moon. This big crater here in the center is about 100 kilometers in diameter. The moon's gravity is pulling the rocket closer, and splat, it hits the surface. And they did this 3 times. And here I'm just showing the last image from one of these Ranger missions. And this here is an image that was taken about 60 kilometers away from the future Apollo 11 landing site. The image was taken about 4 kilometers above the surface. The width of this image is about 400 meters, and the resolution is about 50 centimeters or so. So you can see things that are roughly 50 centimeters in size. And what you can see from this image is that the surface of the moon looks relatively benign. It's just kind of flat, rolling hills. There's no crevasses. There's no big rocks or spires sticking out or anything. So the next step was the Soviet Union. Just about a year later, they landed Luna 9 on the surface of the moon for the first time. And this is showing that one of the panoramas that were taken from the spacecraft. And the first thing is that this spacecraft actually landed, and it landed on the surface. It did not sink through a thick layer of dust, and this suggested that landing on the surface of the moon would be safe. And if you look at these images, they're not the best quality, but you can see that there's some rocks on the surface, but the surface of the moon just appears to be a bunch of broken up small rocks. Now, shortly after this, NASA did the same thing with the Surveyor program. Between 1966 and 68, they landed 5 successful robotic probes on the surface and obtained some better quality images of the surface of the moon. And as you can see in the right image, the surface of the moon does have a dusty layer, but this dusty layer is only a couple centimeters thick. If you look on the left-hand side, you can see that, yes, there are in fact some rocks on the surface of the moon, but these rocks are pretty small and it's nothing that would pose any danger to an astronaut that would be walking on the surface. And at the same time, NASA decided to make images of the entire surface of the moon. They put 5 spacecraft in the orbit called the lunar orbiters, and they imaged 99% of the surface of the moon, both on the near side and on the far side. And the resolution of these images were better than about 60 meters. And in some places where we actually sent humans to the surface, we made images down to as small as 1 meter. And this image here is just showing a picture of the Copernicus crater from one of these lunar orbiter photographs. And this crater is about 90 kilometers across and about 4 kilometers deep. And just to put this in perspective, this crater is twice as deep as the Grand Canyon on the Earth. So if you're a geologist, there's lots of geology and interesting things to do on the surface of the moon. And then finally using these images from the lunar orbiter missions, scientists were able to make a different type of map of the moon. So in contrast to Hevelius and Galileo, who just drew what they saw in essence, a geologic map is different because each color on this map corresponds to a different geological unit. And all you have to do is look in the legend of this map, and it tells you what is the origin of this geologic unit. And it also tells you approximately when the geologic unit formed. So by using this type of map here, the scientists were able to pick out interesting regions where we could send humans to go to the surface of the moon to address interesting scientific questions. Okay, so finally, I'm at Apollo. So Apollo, we had 6 missions which actually landed on the surface of the moon. The first one was Apollo 11, and it's important to point out that Apollo 11 was only on the surface of the moon for 1 day, and the astronauts were only outside walking around for 2.5 hours. And during this time, they only walked about 1 kilometer, and they collected about 20 kilograms of rocks. For the next 2 missions, they spent 2 days on the surface of the moon, and they walked around for about 8 hours altogether, and they went up to about 3 or 4 kilometers away from where they landed. And then with the final 3 missions, they spent 3 days on the surface, and with the help of an electric roving vehicle, they were able to travel distances of up to 36 kilometers. And then over this three-day time period, they were able to collect roughly about 100 kilograms of rocks for each of these missions. Okay, so here I think it's just important to point out that the astronauts were actually trained to be geologists. They were trained to pick up interesting rocks on the surface. And not only that, but they were trained to document the collection of every single sample that they collected. And here's just showing an example of the 2 astronauts documenting some of the samples they're collecting. And once these samples were brought back to Earth, these samples were placed in these stainless steel clean rooms with gloved boxes, and the boxes were filled with nitrogen. And this was just to ensure that people's hands, which are very oily, never touched the lunar rocks, and also that the atmosphere of the Earth didn't come in contact with the rocks either, because the atmosphere can alter the rocks over time. But because of the way the rocks were collected and sampled and then stored on Earth, these samples are still being analyzed today, and they're extremely important for understanding the geologic evolution of the moon. So what do these rocks tell us? Well, in simple terms, there are two types of rocks. There are white rocks and there are black rocks. And the white rocks, these are rocks which are called anorthosites. They're made of the mineral anorthite. These types of rocks, we can find them on the Earth, but they're not very common. But it turns out that these rocks are very, very old. They're about 4.4 billion years old. So these white rocks, which make up the kind of continental crust of the moon, this formed at the same time as the Earth and the moon formed. That's how old they are. Now, in contrast, the black rocks, these are just very similar to lava flows that we see on the Earth. So if you go to any volcano like La Réunion or Guadeloupe or to Hawaii, you will find rocks that look more or less like the lunar lavas. Now, the only difference is that the lunar lavas that we found are somewhat older. They're about 3.5 billion years old. So they're old by terrestrial standards, but they're fairly young compared to the age of the formation of the Earth-Moon system. Okay, so not only did, in addition, well, during Apollo, they collected samples and brought them back to the Earth. But what we also did is we brought things to the moon and left them on the surface. And in particular, what we did is we left a scientific package, which is called the Apollo Lunar Surface Experiment Package, on the surface of the moon. And in essence, you have a central base station, which collects all the data from the scientific experiments and then relays the data back to the Earth. And then this entire setup is powered by a radioisotope thermal electric generator, which generates power over a roughly 10-year time period. So what type of instruments did we put on the surface of the moon? Well, we put seismometers, 4 seismometers on the surface of the moon, and we found out that the moon actually is seismically active. And here is just an example of a lunar seismogram. This is a moonquake, similar to an earthquake. And by using these moonquakes, just like we do on the Earth, we were able to infer what is the interior structure of the moon. And we know that the moon has a crust, it has a mantle, and it has a metal core. So it's very similar to the interior structure of the Earth. I'd say the biggest difference is that the core of the moon is very small compared to that of the core of the Earth. We also put magnetometers on the surface of the moon to measure the magnetic field. And what we found out is that portions of the crust of the moon are strongly magnetized. And not only that, some of the samples, the rocks that we collected on the surface of the moon, were found out to be magnetized as well in a strong magnetic field. And the interpretation of these data is that the moon, just like the Earth, had a global dipolar magnetic field that was generated by its core, and that this global magnetic field magnetized portions of the moon's crust. Now, scientists today are still trying to understand when this dynamo turned on and when it turned off, but based on the data that we have, we know that the moon at some point had a global magnetic field similar to that of the Earth. Another experiment that we had was the heat flow experiment. And the idea here was to measure how the temperature increases below the surface. So what the astronauts did is they drilled a hole about 3 meters deep. This is shown in the left image here. And then you can see the astronaut on the right-hand side putting a thermometer into this hole. And what they were able to do is measure the temperature gradient. It's how much the temperature increases as you go deeper below the surface. And by using these data, we can make inferences as to how hot the moon is in its interior and how hot it was in the past. And this is really important if you want to understand how the lava flow is erupted, because you need to heat up the moon if you want to create a lava flow. And the last experiment I'll talk about is the lunar laser ranging retroreflectors. And in essence, what this is, it's just a box about this big with a bunch of small little glass mirrors. And the properties of this mirror is that if you shoot a laser beam at this box, the laser beam gets reflected directly back at you. And what you do is you can use a very powerful laser at an observatory on Earth, shoot this laser at the moon, wait to see how long it takes for the laser beam to come back. And then since we know the velocity of light, we can determine how far away the moon is from the Earth. And this is kind of just to show what we're measuring. What we find is that, first of all, we can measure the accuracy of between the Earth and the moon with an accuracy of better than 2 centimeters. And we see that the moon kind of wobbles back and forth. And based on the amplitude of these wobbles, we can determine that the moon has a liquid metallic core. It's liquid today, just as the Earth's core is liquid. Also, because of the tides that the moon raises on the Earth, we found that the moon is moving away from the Earth about 3.8 centimeters per year. And importantly, it turns out that we are continuing to make these lunar laser ranging measurements to the moon today. And we're still finding out new things about the moon based on these lunar laser ranging data. Okay, so I'm coming to the end of my story. So in essence, with all this exploration I was talking about during the space race, things stopped relatively abruptly. The last crewed mission to the moon was the Apollo 17 mission in 1972. And then after this, the ALSEP stations that I mentioned, they continued to work until 1977 because they were powered by a radioisotope electric generator. But then NASA turned these instruments off in 1977. And then after this, the moon was in essence ignored by the major space agencies for several decades. There's reasons for this, so you can ask me the questions if you want. But it wasn't until about 1994 where the major space agencies began to become interested in the moon again. And the first mission was the Clementine mission, which was launched by the Americans in 1994. And they had a suite of missions that followed afterwards. Now, what's interesting here is this diagram shows that during the space race, almost all the missions were between the United States and the Soviet Union. But today, the Soviet Union no longer exists and Russia is not on this diagram. However, there are a lot of other countries that have major lunar exploration programs. For example, the European Space Agency sent a spacecraft to the moon in 2003. China has a very strong and very good lunar program called Chang'e, where they put 5 spacecraft either in orbit or on the surface of the moon. So 3 of the Chang'e missions, they landed on the surface, and one of them just 2 years ago, or just last year, collected samples and brought them back to the Earth, and the Chinese are analyzing these data right now. Now, in addition to China, the Japanese, they put a spacecraft in orbit around the moon in 2007. Israel, they tried to land a satellite on the surface and also unfortunately failed. And then India tried to land a spacecraft on the moon, but that failed as well. Okay, so this is my last slide. And this is just to say that people are probably thinking like, what's the next step? And when you look at some of these TV series like The Expanse or some other science fiction things, you may have this global vision of soon there will be these colonies on the moon with hundreds to thousands of people, and there will be space flights going back and forth between the moon. I think what you need to expect is that this is something that will probably happen in our lifetime. This picture here is just showing a small lunar outpost where parts of the outpost are brought to the moon by humans, and other parts of the outpost are built using lunar materials. So this is something that I hope to see in my lifetime. I'm not sure who is going to construct this space, if it'll be Americans, Chinese, Russians, Europeans, but in any case, I'm sure that the future of lunar exploration is going to be a very international endeavor. So thank you very much. And if you have any questions, I'm happy to stick around and answer them.